Hey there, everybody. In this video installment, we are going to be adding and subtracting rational functions. Now, before we get too far in this, I should make mention that adding and subtracting tends to be much more difficult than multiplying or dividing. So, we got to put our math pants on and make sure that we are ready to go and buckle up because it might be a rough ride. Now, as we're going through, if at any point something doesn't make sense or if I'm going too fast, feel free to pause the video, rewind it, and always, you guys are free to shoot me an email, and I will happily walk you through something that doesn't make sense. So here we have an example of two rational functions, 8 over 7v minus 6 plus 4 over 3v squared. Now, if I were to kind of take a sidestep here and look at an example, say 1/2 plus 1/3. If I wanted to add those two fractions, plus, not times. I can't add these directly because the denominators aren't the same. I have to have common denominators to add or subtract, and clearly I don't have that. So what I could do is I could make this have a common denominator by changing them both into a 6, since they both go into a 6. Well, 1/2 is the same as saying 3/6, because to turn a 2 into a 6, I'm multiplying top and bottom by 3. So this would be 3/6. To turn a 3 into a 6, I'd have to multiply by 2. Whatever I do to the bottom, I have to do to the top. So that would give me 2/6. Then adding those together, I would get 5 over 6. Can I reduce it? Nope. That's our final answer. So essentially what we're doing is we're finding what is the common denominator, what denominator works for both of the previous denominators, and then from there we're saying, well, what is this guy missing to turn into the denominator we want? All right, so let's look at a rational example. First step, as always, try to factor if you can. 7v minus 6, there's no GCF, can't really factor. 3v squared, that's one single term, can't really factor that. So what I like to do is I like to put little parentheses around different factors. So 7v minus 6, that's one entire unit. This 3 is its own beast, and then the v squared is also its own beast. Those are connected through multiplication. So our common denominator has to have all of these components. It has to have a 7v minus 6, it has to have a 3, and it has to have a v squared. So my common denominator has to have a 7v minus 6, it has to have a 3, and it has to have a v squared. Now in a second here, I'm going to rearrange these because I'm not a huge fan of writing things in this order, and you'll see that in a second. So again, I'm rewriting these just like we did on the previous one so that we have our common denominator. All right, the first one, we already have the 7v minus 6, but we're missing the 3, we're missing the v squared. So I need to multiply by a 3 and a v squared. Well, if I do 3 times v squared times 8, 3 times 8 is 24, so I have 24v squared. Plus, on the second one, I already have a 3, I already have a v squared, but what I don't have is this 7v minus 6. So I need to multiply top and bottom by 7v minus 6, and I'm realizing now that I forgot to do that to the bottom over here. Shame on you for not saying anything. So when I do that, I can distribute. This is a positive 4. I'll distribute the positive 4 onto 7v minus 6. That's going to give me a 28v minus 24. 28v minus 24. So now these clearly have the same denominator. And what I'm going to go ahead and do is I am going to combine both numerators over the shared denominator. So my shared denominator is, and I'm going to rearrange things like I said, 3v squared times the quantity 7v minus 6. If I wanted to, I could distribute that out. I'm not going to, but I can. Let's see, do we have like terms? 24v squared? No. So no like terms up top. So this would be 24v squared plus 28v minus 24. If we can simplify, we will. Let's see, up top there'd be a GCF of 4, but that 4 wouldn't really cancel anything out down there. So we're going to call this one complete. Let's see a different format of 1. Here we have 4 over n plus 7 minus the 7 over the quantity n minus 2. So these ones don't really have any factoring, but I went ahead and threw parentheses around each denominator. So my common denominator has to incorporate both of these aspects. My common denominator has to have an n plus 7, and it also has to have an n minus 2. So my common denominator needs an n plus 7, and it also needs an n minus 2. Another thing I like to do with these, since it has a subtraction sign here, is I'm going to change that to a plus, and anything that comes after that, I'm going to make it the opposite. So positives turn negative, negatives turn positive. All right, the first portion here, we already have the n plus 7, but what we're missing is the n minus 2. So I need to multiply an n minus 2 to top and bottom. When I do that, I distribute 4 times n, 4 times minus 2, and I'll get 4n minus 8. Plus, I've got a negative 7 over n minus 2. Well, to turn an n minus 2 into an n plus 7 n minus 2, I need to tack on that factor of n plus 7, but whatever I do to the bottom, I must also do to the top to maintain equality. And this would give me negative 7, if I distribute, negative 7n minus 49, negative 7n minus 49, all over our common denominator. Now from here, since we have the same denominator, we are going to combine like terms from our numerators. So my denominator again was n plus 7 and n minus 2. And I should make note, if you had these backwards, it doesn't matter. If you have n minus 2 first, it doesn't matter. Up top, we're going to have 4n. That can only combine with other n's. So 4n plus negative 7n, I'm getting negative 3n. Next, I have negative 8 plus negative 49. Negative 8 plus negative 49 is a negative 57. Negative 57. Now from here, if you really wanted to, you could factor out a negative 1, and you could call that negative 1 times the quantity 3n plus 57. That is totally legal. Or you could even go one step further, and you could factor out a negative 3, because after all, these are both divisible by 3, and you could call that an n plus 19. Typically, we only want to do that if we notice something might cancel. So by factoring out this numerator here, yeah, it looks a little bit cleaner, but nothing's canceling, so it's almost like I did that step for nothing. All right, one last and final example. Here I've got 3x over the quantity x squared plus 8x plus 12 plus 4 over x plus 2. First thing I'm noticing, this right here is not factored. So let's take care of that. 3x doesn't have to change, but the denominator becomes, let's see, what multiplies to 12 adds up to 8? Multiplies to 12 adds to 8. 6 and 2, or 2 and 6, however you want to write it. Plus, I don't have to worry about switching any signs, 4 over x plus 2. So the only thing I did to go from step 1 to step 2 is factor the bottom. All right, my common denominator. According to this guy, I need an x plus 2 and an x plus 6. And according to the second term, I need to have an x plus 2. Well, I've already got that. Okay, so I really don't need much more. Again, common denominator, x plus 2 and an x plus 6. So for the first expression here, my denominator is already basically complete. I don't need to change it at all. If you really feel hell-bent on multiplying top and bottom by something, multiply by 1. It doesn't matter. It's not going to change much. On the other side of things, this one already has an x plus 2, but it's lacking an x plus 6. So I need to give that both to the top and to the bottom. In doing so, when I distribute, that gives me 4x plus 24. So now we'll combine our like terms. We'll write this as one big happy fraction. My denominator was x plus 2 and x plus 6. My numerator, after like terms have been combined, is going to be 7x plus 24. And we're done. Hope that helps. Let me know if you're stuck.